Hello, today I'm going to show you how to do this second order initial value problem, what I like to call the fast and easy way. Now, in order to start something like this, you have to realize that we need to put it in normal form. So, divide by t to leave y double prime exposed. The equation I'm going to show you is actually based off of the reduction of order method, which I have given in another video, except it takes that method and it basically compresses all the steps into a very straightforward form of the question. This is the equation itself. This y1 will be given in your question. In our case, it's e to the power of negative t. And this is e to the power of negative the integral of pt. And p at t is the thing that's attached to the y prime. Now, why does this equation look like the way it is? It's a very long proof, but you should know that the v comes from this, right? We're solving for y2 first, so that we can find the general equation, which will be in the form of this, where c1 and c2 are constants. Okay, now that I've explained that, hopefully it makes a little bit of sense. If it doesn't, maybe solving this question will help you out. Let's begin by taking the equation I just wrote and plugging everything in. So you got your 2t plus 3 over t. Don't forget the dt. If you forget it, I guess it's not really a big deal, as long as you know that you're taking the integral with respect to t. And then we take the integral. This integral shouldn't be too difficult, because what I did here was I simply realized that the numerator and the denominator could be split up into two terms, 2t over t plus 3 over t. And then I just took the integral of it. The integral of 2 would be 2t, and the integral of 3 over t would be 3 ln t. Then I moved the negative in. So here, what can we do here? We can realize that since there's a negative e to the power of negative 2t up here and an e to the power of negative 2t down here, you can cancel it. But why can you cancel it? Well, that's because this big blob up on the top can actually be rewritten as this. I will try to explain why, hopefully. Saying something like this is synonymous to, on the side, an example, x squared multiplied by x of negative 2x squared. What is this? X to the 2 minus 2x squared. See? I just kind of smushed the terms together, and now I'm pulling them apart again so that I can cancel them. Okay, so let's continue. E to the power of ln anything is the thing inside the ln. In this case, the thing inside the ln would be t to the negative 3. So now you got your v prime at t. It's t to the negative 3. But what we really want is v at t. What we'll do, we just take the integral of both sides with respect to t. This part is pretty easy if the equation that you were given initially was straightforward, such as this example. Yeah, you should be very thankful if you get something like this, actually. Okay, so what is this? T to the negative 2, negative 1/2. How did I do this? Well, when you take the derivative of this, you know that you have to subtract 1 from it to get negative 3, right? So I just added 1 on the thing up here to get negative 2. Also, you know the coefficient is going to be 1, positive 1. But you also know you're going to bring down a negative 2. Well, negative 2 multiplied by what number gives you positive 1? Negative 2 multiplied by negative 1/2 gives you that. We solve for y2. Just gotta plug it back into this equation, right? y2 is equal to e to the negative t multiplied by negative 1/2 t to the negative 2. Yes, it doesn't get much simpler than that. It's always going to look pretty ugly. Let's put it into the general equation. Now, sometimes your professor will be really nice to you and not give you initial conditions so that you don't have to continue solving this question, but in our case, we're not so lucky because the original equation gave us y at 1 equal 5 over e and y prime at 1 equal 3 over e, which means we have the lucky opportunity to solve for C1 and C2. How are we going to do this? Well, first you got to realize that C1 and C2 are two unknowns, and in order to solve for two unknowns, you have to have two equations. Well, we only have one equation here, but we can create another equation by taking the derivative of this general equation. Now what would that give us? Let's see. This is a constant. Keep it like that. So I'll take the derivative with this piece first. This is the product rule. So e to the negative t, t to the negative 2 plus c2 e to the negative t, t to the negative 3. Okay. Now what do? We can plug in 1 where the t's are, and we can plug in 5 over e where the y is for this guy in the general equation, and 3 over e for y prime, because that was specified initially. With ugly questions such as this one, I would say my word of advice to you is, this is a 1, sorry. My word of advice to you is to always make sure your negatives are in the right place. Because very frequently you're going to have to add and subtract terms, sometimes multiple terms at once, and if you can't keep track of whether you're adding things or not, you're gonna have a big issue. Or at least that's what I find happens to me most frequently. Okay, so now we've plugged all the terms in. You can see that because the numerator on every term is actually going to be e, you could just get rid of the e's in both equations. By what would happen is you would multiply both sides by e. 1 1/2. So that's the general equation I just wrote here. 3 is equal to negative c1 plus c2 plus c2. Yep. This is really convenient because you can realize that if I draw a line here and I add these two equations, my C1s are actually going to cancel, these C2s are actually going to cancel, and I'm going to be left with a C2 term. Sometimes we're not going to be that lucky, but I mean, take what you can get, right? So, you can see that C2 is equal to 8, and if we go back to this equation up top, 5 equals c1 plus c2, negative 1/2, and we plug in c2, c1 plus 8, 1/2. We find that c1 is equal to 9. We're almost done. Don't forget to plug your values back into your original equation, especially if this is a long answer question. Plus 8 by negative 1/2. E to the negative t, t to the negative 2. I'm going to simplify this. Y is equal to 9 over e to the t minus 4 over e to the t, t squared. Yep. And there you have it. That's how you would solve this equation my way, which I consider simpler than the long equation. Some professors do give this to their students, and some don't. I have yet to understand why. But if you do move up in higher level math, or later in Calculus 3, I would assume that you want to do it the long way. For multiple choice questions on a test or something, you could use this method. I wouldn't see an issue in it. As long as your y1 isn't 0, but when's your y1 going to be 0, right? Alright, hope that helped. If you guys have any specific questions, please leave it in the comments.